Go.
I'm going to check the temperature. There's nothing here inside, just the solid zinc. And I'll tell you what is the temperature. You can see probably here the temperature. But the glass right now is showing 70.0 Fahrenheit. Did you see it? What is that? What temperature is showing there?
69.6, it looks like.
Okay. We'll see this increase in temperature after we add sulfuric acid. If you're going to add sulfuric acid, you will see formation of the gas there. Generate the gas. The gas, hydrogen gas, will displace the air from the tube and here, and then the hydrogen gas will come out here. We want to have a hydrogen gas atmosphere inside the tube. That hydrogen gas will displace the oxygen from the copper oxide, leaving behind the pure copper, the copper metal. We'll see that transformation by the color change. Color change also is a good indicator that a chemical reaction is happening. We'll observe that here. I'm going to add now the sulfuric acid, just a little bit to get this started. I'm going to add about half of this volume slowly. Remember, when we are working with concentrated acids or bases, we need to handle that very careful. Slowly. That should be enough. And you can see the reaction already started. I'm going to move it a little bit to create more contact between the acid and the metal, and temperature at this point should start to rise. Let me know what temperature is now.
72.5.
I'm going up. So that proves that we have an exothermic reaction. Let's go to this part. Let's see what's going on here. I'm going to collect the gas. Remember, here this reaction is generating hydrogen gas and also water. However, we have a water trap that will collect all the water formed here and let only hydrogen go through this tube. So I'm going to collect something there. I hope that is hydrogen gas. How do we know we have hydrogen gas? We are going to do a hydrogen gas test. That is the reaction between hydrogen and oxygen. That produces a pop sound. That's why it is called the pop hydrogen gas test. It is called also the hydrogen barking. Let's see, we have enough hydrogen gas in that tube. Did you hear it? Look. So it's on. You can see the flame. I hope you can see the flame there. I'm going to put this background there. Can you see it? That means that yes, we are generating hydrogen gas and the tube is filled only with hydrogen gas, and the extra hydrogen gas is coming out here and is reacting right now with oxygen present in the air. That proves that we have another chemical reaction there, the reaction of hydrogen gas and oxygen to form water. We are ready to start the reaction because that's all what we need. We have the copper oxide, solid. We have the hydrogen gas, but we need to activate these two so they can start making the reaction. We need to introduce some heat, some energy. Let me add a little bit more of hydrogen to keep this active. And you can see the flame here. As I add more acid, it increases the formation of gas. So again, we need to activate these two components, hydrogen gas and the copper oxide, which is the black oxide. How do we activate them? To start the reaction are in heat. Heat is energy, and that will increase the activation energy right enough to start the reaction. But what I'm going to do is I'm going to hold up on, so this is the way you